Okay, so there's a lot going on in the C++ language. And so I want to talk a little bit about all the different ways you can make constructor calls. Because constructors show up a lot. Probably, as soon as you start making any kind of object, you're going to want constructors. And then how you invoke those constructors becomes essential to getting the behavior that you want. And so I want to describe a couple of different forms of construction, explicit and implicit constructors. All right, so what this is really getting at is when you construct an object, are you explicitly pointing out the constructor to call or only implicitly pointing out the constructor to call? So it can be done in either way. And it may look a little funny to you at first because I haven't done it this way, but one way you could call a constructor is an explicit form. So using that rectangle object that we made in the default constructor video, we know that we could either pass in two integers like this, or we could pass in none and use a default constructor. So this form where I say r equals and then name the constructor, rectangle, and then pass in two integers, this is an explicit call. I'm literally saying, hey, call that version of the rectangle constructor that takes two integers and use that to initialize r. On the other hand, down here, where I just name the variable r1 and don't do anything else, this is really kind of an implicit call. The constructor is going to run here, but it's the default constructor that's going to run. It's implicit because it's implied. It's not something you see written out in the language. And this is very different than C, right? Whenever we write C code, if a function is running, it's because we explicitly called the function. But now in C++, functions run even when we don't explicitly ask for them to. And we have to remember this and keep it in mind because there could be really important behavior that's, embedded in those constructors. I mean, I could actually close in the program inside the constructor if I wanted to. I could call another program to do something. I could, do any manner of weird things within a constructor. It wouldn't be a good idea, but it's possible. And you don't even see that it's happening, explicitly written out in the code. But anytime you have an object and it's being constructed, right, being declared and constructed, there's a function running. So, sometimes we point out whether we're talking about explicit or implicit construction. And explicit means you literally see the call to the constructor in the program. But implicit means that you don't see it at all. It happens nonetheless. Here are some implicit forms with parameters, right? So this call here to create variable r2 will call the version of the constructor that takes two integers. And here I'm not writing out the full function name and saying equals rectangle 5100, but it means the exact same thing. It just means, look, pick the right version of the constructor and call it. It doesn't look like a call, really, from a C code perspective. It does a little bit because there's an identifier followed by parentheses, but there's a function call there nonetheless. Okay, now you might be tempted to make a default constructor call the following way, like let's create rectangle R3 and then put open and close parentheses after it to indicate to the compiler to call the default constructor. Honestly, it makes perfect sense. Why wouldn't that work? But it doesn't work. It's a syntax error. So the only time we can use this implicit notation is with a parameterized constructor. Okay, the other thing I want to point out is it may seem like, why do I ever need to do explicit construction? Why can't I just always do it implicitly? There are times when explicit construction is very useful. Let's say I'm passing a rectangle to a function and I want to give that rectangle a default value. Well, the code might look something like this. So I'm going to have a function called draw. Maybe I'm going to draw the rectangle on the screen. And then I pass in a rectangle R into this function. And if the programmer so chooses, they can omit an argument. And if they omit the argument, then we'll replace it with a rectangle of unit length. So in other words, a square. And And we specify that by saying R equals, and then we explicitly specify the constructor we're going to use and the arguments we're going to pass. Right? So in this case, R can get replaced by a rectangle with a length of 1 and a width of 1. And then the only way to specify this default value in C++ is with an explicit call to the constructor. So this is one place where these explicit calls come really in handy. And you need to be aware that those explicit calls mean the same thing as the implicit calls. It looks weird, it kind of looks verbose, but they have the same meaning. And then there's that weird case where you can't call the default constructor using empty parentheses because it doesn't work. It's a syntax error. The reason that's a syntax error because it looks to the compiler like a function declaration, and there's just no way to get around that. It's something C++ inherits from C, and not easy to omit. Okay, so in summary, just because you don't see a constructor call written out in the code, that doesn't mean it's not there, both for default constructors and implicit constructors. Right, default constructors will be called implicitly on your objects in the absence of an explicit construction. And even though explicit construction is a little bit verbose, it is necessary at times, like when giving function parameters default values. And you will see it in C++ code that you go out and look at online. There are going to be times I ask you to go look at documentation, or go figure out how an object works so you can use it in an assignment. And you may see explicit construction in some of that documentation. I don't want it to confuse you. Okay.